Okay, today we'll be doing multiplying polynomials. So our objective for today, our essential question is how do we multiply polynomials? And what type of expression is the result? So remember, on the last couple days, if we added two polynomials, our result was a polynomial. If we subtracted two polynomials, our result was a polynomial. So today we'll have to see if it holds true for multiplication as well. Now we're going to be skipping the explore portion and we're going to be going straight to explain 1. Now back in Algebra 1, you learned how to multiply a binomial times a binomial. Remember, binomial means two terms. Okay, and so we'll just be expanding on that same concept. Now the things you need to know to be able to multiply polynomials is you need to know the product rule for exponents and the distributive property. The product rule for exponents tells me that if I have the same base being multiplied together, so notice here my base is x, then what I'm going to do is I'm going to add those exponents. I'm going to add those exponents together. So the only time our exponents get bigger is if we multiply the bases. Then we're going to add the exponents. The distributive property, that one tells me that if I have something in front of a quantity in parentheses, then it's going to multiply by every item inside those parentheses. It's going to multiply by every item inside parentheses. Now, when we have a product of two monomials, when we have a product of two monomials, it's going to be a product of the coefficients, and then it's going to be a sum of the exponents of each variable. So over here, notice I have 5x times 6x cubed. So the 5 times the 6 multiply to make 30. And then x and x cubed, well, that's x to the first times x to the 3. So we add the 1 plus 3 together to get x to the fourth. On the next one, you have a -2 and a 5. So you multiply those coefficients to get -10. And then you have to look at each variable independently. So I have x squared and no other x's, so it stays x squared. I have y to the fourth and y squared, so I get y to the 4 plus 2. And then I have z and z. Again, if we don't see an exponent, we assume there's a 1 there. So then 1 plus 1. And so now I end up with -10 x squared, y to the 6, z squared. Notice it's in alphabetical order. Okay, standard if we have multiple variables is to put them in alphabetical order. Now when multiplying two binomials, the distributive property is used. Some of you may have heard of this property referred to as FOIL. You want to be careful using the words FOIL because they only work if you have two terms multiplied by two terms. So that only works for binomials. Okay, but what FOIL really is the distributive property. So what you're doing is you're taking the 2 and you're distributing it to both items in our parentheses. So notice my 2 is being distributed to the second binomial. And distributing it to the second binomial is really distributing it to each item in the binomial. So notice the 2 gets multiplied by both the 1 and the x. So we end up with 2 plus 2x. So we end up with 2 plus 2x. Then I'd go to my next term in my binomial, and I distribute it to everything in the second binomial. So the 3x multiplies by that whole thing, but multiplying the 3x by that whole binomial is the same as multiplying the 3x times each item in the binomial. So that's really 3x times 1 is 3x. Oh, sorry, they did it in a different order. 3x times 1 would be our 3x, the one on the right over here. 3x times x, well, that's x to the first times x to the first. That's 3x squared. The last thing you have to do is you have to combine your like terms. So you go through and you look for your greatest exponent. And so one thing the book does not write it in standard form, and they should be. So I'm going to go ahead and do that. So I look for my greatest exponent. So I start with 3x squared. So I get 3x squared. Then I look for any like terms. And my next ones would be the x's. So 2x plus 3x is 5x. And then last but not least, we have our constant of 2. And so we'll add that to the end. So notice in this situation, the only like terms were the x's. This is called a trinomial because there are 3 terms. So if there's 2 terms, we call it a binomial. If there's 3 terms, it's a trinomial. If it's anything bigger than 3 terms, we'll just use the generic polynomial. Now, I am not going to be following all the steps that the book has on the next examples. So feel free to look through those if you would like, but I will be doing it just based on the heart of distributing. Okay, so I'm just going to do it based on the heart of distributing, look a little more like what you saw in Algebra 1. So I'm going to start with my first term. My first term is x, and I'm going to multiply it out. So I get x times 1. Well, that's x. Then I distribute it again, and I get x times negative 4x. That's negative 4, and the x times the x makes x squared. But now this is where it's different from Algebra 1. Now there's a third term, so I have to distribute my x again. And x times 2x squared, that is 2x cubed. Next, I'm going to take my 2 and distribute it. So I'm going to get 2 times 1 is 2. I'm going to get 2 times negative 4x is negative 8x. And now I have to distribute that 2 again. So 2 times 2x squared is 4x squared. I need to write this in standard form. So part of writing in standard form will be combining my like terms. So I'm going to go through and look for my greatest exponent. My greatest degree is 2x cubed, and there's only one of them. So that will go in front as 2x cubed. Then I'm going to look for any other like terms. So I go to my x squareds, and I have negative 4x squared plus 4x squared. Well, negative 4 plus 4, those two are actually going to cancel each other out. After x squared would come x. So I have x and negative 8x. That's really 1x minus 8x. And 1 minus 8 is negative 7. So I get negative 7x. Notice that now that I'm adding, I don't change any exponents. Now that I'm adding, I do not change any exponents. And last but not least, I have my constant hanging out here too. So my 2 goes on the end. So my answer is 2x cubed minus 7x plus 2. So I have a cubic trinomial. All right. Next problem. They're doing a vertical method here that's similar to how you learned multiplication of 3-digit numbers. Again, I would like us to focus on what is multiplying, and multiplying is distributing. So we are going to just focus on distributing. If you would like to see how to do this method, feel free to watch the Mr. Burger videos. So I'm going to start with my first term, and I'm going to have to distribute my first term 1, 2, 3 times. So I'm going to get 3x times 2, and 3x times 2 is 6x. 3x times x, that's 3x squared. 3x times negative 7x squared, that's negative 21, and x times x squared is x cubed. Then I move to my second term, and notice this time my second term is a negative, so that's negative 4. So I have to distribute the sign as well. So I get negative 4 times 2 is negative 8. Negative 4 times x is negative 4x. And negative 4 times negative 7x squared is positive 28x squared. So now I'm going to go to combining my like terms and writing it in standard form. So I start with my cube. So I'm going to start with negative 21x cubed. Then I look for any x squareds, and I have 3x squared and I have 28x squared. So 3 plus 28 is 31x squared. Next, I go to my x's. So I have 6x minus 4x, and that makes 2x. And last but not least is my constant, negative 8. So this time it's a cubic again, it's x cubed, but I have 4 terms, so this is a polynomial. We have a cubic polynomial. I now want you to try number 3 and 4. So while you try 3 and 4, please pause the video. When you are done trying 3 and 4, unpause the video and check your answers. All right, please check your answers. Check your answers and make any corrections as needed. Pause if you need to a little longer to check your answers. So next we're going to go on to modeling. In Algebra 1, we usually kept some aspect of modeling problems fixed at a constant rate, even though in reality, multiple things will change over time. So for example, in the cost of items, the number of items produced can change over a number of years, but so can the cost. Cost of production does not stay constant because wages go up, taxes change, the cost of the materials will change. So cost to produce changes in addition to the number of items produced. So both of those together will affect your total cost to manufacture something. So Mr. Silva manages a manufacturing plant. And from 1990 to 2005, the number of units produced in thousands can be modeled by the number of units in terms of years since 1990 equals 0.02x squared plus 2/10 x plus 3. And the cost per unit can be modeled by negative 0.02x squared minus 1/10 x plus 2. And that's years since 1990. So we want to write a polynomial that can be used to model Mr. Silva's total manufacturing cost for those years. So total cost would be the cost per unit times how many were produced. So notice our total is n of x times c of x. Now, I will not be doing this multiplication the way the book does. All right, and so for the first example, you can look through to see how the book does it. For the second one, we will do it from scratch using distribution. So when they multiply, they're multiplying 3 terms by 3 terms. So notice they start by multiplying this right term to each of those. Then they shift it all over one. And then they multiply the second placeholder, the second term, by everything. And they shift it over one and do the third one times everything. Okay, and then by lining it up like that, it combines all the like terms. So we'll actually look at this for Ms. Lau in her dresses, but we're going to use distribution. We're just going to use regular distribution. So Ms. Lau is running a dress company from 1995 through 2005. The number of dresses made can be modeled by n of x. The average cost to make each dress is modeled by c of x. All right, and we want to write a polynomial that can be used to model Ms. Lau's total dressmaking costs, t of x, for those years. So that's going to be the number of dresses made times the cost to make. So that's going to be 0.3x squared minus 1.6x plus 14 times negative 0.001x squared minus 0.06x plus 8.3. Now, in modeling problems and real-world problems, things are not pretty. And that's okay for them not to be pretty. But that means it's time to use a tool. So you may not be able to see it, but I am grabbing a calculator right now, because a calculator is an excellent tool to be able to do this problem in a reasonable amount of time. Now notice, previously we were doing 2 terms times 3. This time I have 3 terms times 3 terms. So I'm going to have to multiply each of these 3 terms by each of these 3. So I'll end up with 9 terms before I simplify. So I'm going to take my 0.3x squared and I'm going to distribute it once. And so I'm going to get my 0.3 times 0.001. And it's negative, and so I'm going to get negative 0.0003, and x squared times x squared is x to the 4th. Then I'm going to distribute it again and get 0.3 times negative 0.06. And so that's going to be 0.018, and x squared times x is x cubed. I have to distribute again. And so I'm going to get 0.3 times 8.3. And I'm going to get 2.49. 2.49. And then it's going to keep the x squared. Now I go and distribute my next term. So now I need to distribute negative 0.6. So I'm going to distribute it times the negative 0.001. And so that's about a matter of moving the decimal places. So it's going to be 0.0016. A negative times a negative is a positive. So 0.0016, and x times x squared is x cubed. I have to distribute it again. So I get a negative times a negative again is a positive. I get 1.6 times 0.06, and I get 0.096. And x times x is x squared. I have to distribute it again. And so now I get negative 1.6 times 8.3. And I get 13.28. But a negative times a positive is a negative. So negative 13.28. And it's going to keep the x. But notice 14's been hanging out here. 14 hasn't been touched. That's because we now need to go and distribute 14. So my positive 14 I'm going to distribute. So I'm going to get negative 0.014x squared. I'm going to distribute 14 times 0.06. And I'm going to get 0.84 x. Positive times a negative, so minus 0.84 x. And then I have to distribute it one more time. So I get 14 times 8.3. They're both positive. I'm going to get positive 116.2. So notice I get this really long polynomial with 9 terms. So now I need to combine like terms. So I'm going to start with my greatest exponent, x to the 4th. And since there's only one of them, I'm going to go ahead and write that down here in front. So 0.0003 x to the 4th. I'm going to check it off as I go through. Next, I have cubes. So I have negative 0.018 x cubed, and I have 0.0016 x cubed. So I need to combine both of these. And so I get negative 0.0164 x cubed. I'm going to check them off. Then I have my x squareds, and notice I actually have 3 different x squareds. So I need to combine all 3 of them. And so that's 2.572 x squared. And I'm going to cross off as I use them to just, especially in these larger polynomials, I want to keep track of what's still left. So then I have some x's. I have 2 x's to combine. So that's negative 13.28 minus 0.84. That's negative 14.12 x. And then that still, don't forget the constant. That constant is going to add on here. And so here's my polynomial. This represents Miss Lau's total cost of her dress company from 1995 to 2005. So your homework for today is to go to page 290, and you are going to work on 2 through 8. I expect you to begin these problems in class, work through them in class, check your odd answers with the QR code, and check your even answers by seeing if your neighbors are getting the same responses. Go ahead and begin.